Hey everyone, Mr. Phil's Avatar here with another devlog update. Yesterday, I worked on Stellar Throne, my 4X strategy game, and made huge progress on the user interface integration. For those just joining, I'm developing Stellar Throne with a dual engine architecture, Godot for the production client and Zig for the high performance simulation engine. Yesterday's session focused entirely on making the Zig version fully interactive with real game UI. The main challenge was bridging the gap between the Headless simulation engine and an actual playable game. I had 30 core gameplay systems implemented, 607 tests passing, and 98% parity with the original Godot game. But it was all headless code, command line testing only. No graphics, no UI, no way for a human to actually play the game. Yesterday changed that. I integrated Dear ImGui, which is a popular immediate mode UI library commonly used in game development. This required setting up the entire UI rendering pipeline, including Sokol_GFX for graphics backend, Sokol_ImGui for ImGui integration, and CImGui, which provides C bindings for ImGui that work with Zig. The challenge was getting all these pieces working together with SDL3 and Metal on macOS, while keeping the codebase headless compatible for simulation testing. The first major step was fixing the Metal rendering pipeline. I created a platform abstraction layer that handles SDL3 Metal integration. This involved creating SDL_2_Sokol.zig, a 199-line module that translates between SDL3's coordinate system and Sokol's rendering expectations. The key issue was high DPI/Retina display support. On modern Macs, the physical pixel density is twice the logical coordinates, so a window that's 800 by 600 logically is actually 1600 by 1200 physically. I had to track both coordinate spaces and apply proper scaling throughout the rendering pipeline. Next, I built out the comprehensive UI system. I started with a galaxy map visualization, showing all star systems as colored dots, with empire ownership indicated by color. This uses Dear ImGui's background draw list to render the galaxy as a persistent backdrop. Then, I added 6 tab screens: Galaxy Map, Empire Overview, Fleet Management, Planet Management, Research Tree, and Diplomacy. Each screen connects to real game data from the managers I built in previous sessions. The breakthrough moment was making fleets actually move on the Galaxy Map. I implemented interactive fleet selection, where you click a fleet to select it, and it highlights in yellow. Then you click a destination system, and the fleet pathfinding kicks in to plot a route. The fleet moves turn by turn along that route, and you can see it travel between systems on the map. The pathfinding uses the same breadth-first search algorithm from the original Godot version, so it's perfect parity. After fleet movement, I tackled construction. I added build ship and build building buttons to the system information panel. When you click them, modal dialogs appear showing all 12 ship types or 14 building types with their costs and descriptions. Select one and it starts construction. Progress bars show real-time build progress, and when you click Next Turn, the construction manager processes everything automatically. Ships spawn in the system's fleet pool. Buildings add to planet production. This whole workflow involved adding 244 lines to the Galaxy Map UI, including ship and building selection modals. I also fixed a subtle bug where planets weren't being properly initialized. Planets should inherit their parent system's ownership, and they should spawn with starting buildings like a colony hub and shipyard, plus 5 million population. This was a one-line fix in game state initialization, but it had cascading effects throughout the construction system. Without starting buildings, players had zero production and couldn't build anything. With them, the economy flows naturally from turn 1. The final piece was making the Galaxy Map render as a persistent background layer. I split the rendering into render background, which draws directly to ImGui's background draw list, and render overlays, which draws UI panels on top. This creates a floating panel effect where the strategic map is always visible behind your UI screens. It's a huge improvement for visual polish and strategic awareness. From a technical perspective, this session added over 8,000 lines of code across 32 files. The main additions were 7 new UI modules totaling 1,460 lines, plus comprehensive documentation in the docs directory, covering SDL3 / Sokol integration, metal rendering, and UI progress. The codebase now sits at roughly 18,000 lines across 94 files, with 96% compliance with my CLAUDE Engine V2.0 architecture that keeps files under 300 lines. All 607 tests still pass at 100%. The Headless simulation mode still works for AI testing and balance verification. And now, the visual game mode is fully operational. You can launch the game, see the galaxy map, click fleets to move them, build ships and buildings, and watch turns process in real time. The result is a complete interactive game loop. You move fleets to explore and conquer. You build ships to expand your military. You construct buildings to grow your economy. You click next turn and watch everything process. Resources collect, construction advances, fleets move between systems. The foundation is rock solid. Next session, the priority is making the research tree fully interactive. Right now, it displays all 76 technologies across 5 disciplines, but you can't click to research them yet. I need to add click to select functionality, prerequisite validation, a begin research button, and real-time progress tracking. Once that's done, the core gameplay loop will be complete. Move fleets, build infrastructure, research technologies, advance turn, repeat. After research, the focus shifts to planet management pop-ups. When you click a planet, a detail window should appear showing buildings, population, and resource output. This will tie into the construction system, so you can queue buildings specifically for individual planets, instead of just system-wide. From a parity perspective, I'm now at 98% parity with the original Godot version. The remaining 2% includes events, espionage, and alliance systems. But the core 4X gameplay, combat, economy, research, and victory conditions are all implemented and tested. The simulation engine can run 1,000 turn AI battles in under 2 seconds. The visual game renders at 60 frames per second with smooth UI. This project demonstrates the power of Zig for game development. The compile time features let me toggle SDL3 on and off with a simple build flag, keeping the codebase clean for both headless and windowed modes. The memory management is explicit and leak-free, verified by 607 tests. The performance is exceptional, with turn processing that would take minutes in Godot happening in milliseconds in Zig. That's the development update. Check out MrPhilGames.com for more. Thanks for watching.